dear students, welcome to today's session. So in today's session, let us understand another topic from the lesson periodic classification of elements, and the topic is Mendeleev's Periodic Table. The scientist by the name Mendeleev, he arranged the elements based on their fundamental properties and their atomic mass and also on the similarity of the chemical properties. I repeat, Mendeleev arranged the elements on the basis of the fundamental properties and the atomic masses and also on the similar chemical property. But the chemical property was given the first priority. While he was arranging the elements were given the first priority on the basis of the chemical properties. And at that time, there were 63 elements which were known, and Mendeleev first tried to find out the relationship between the atomic masses of those elements, physical properties as well as the chemical properties. For this, Mendeleev selected hydrogen and oxygen for the reaction, for the chemical reaction which he wanted to do with other elements which are found in the periodic table. So Mendeleev selected two elements, that is the hydrogen as well as the oxygen, because the hydrogen and oxygen were considered to be a very reactive elements and they can easily react with other elements to form the compounds with those elements. I repeat, he selected hydrogen as well as oxygen because hydrogen and oxygen were very reactive elements. They can easily react with other elements and they can form the compounds with those elements. Correct? So how they're forming the compounds with the elements, let me give an example for you. Suppose you think the element is X. This X may be any element in the periodic table. This X, if it is reacting with the hydrogen, it may form a compound like XH. It can form a compound like XH2. It can form like XH3. It is maybe anything. It's an assumption. Okay. So it can form like this. Let us suppose now if an element react with oxygen, if an element is X and if it is reacting with the oxygen, it can form a compound like XO, XO2, X2O3 and so on. So this is how he has reacted the elements along with the hydrogen and oxygen. And hydrogen and oxygen, they were easily reacting with these elements and they were forming the compounds with those elements. Clear? So based on this property of the elements, he reacted different elements with in different ways. Correct? So similarly with the hydrogen also, it can react in many ways, and oxygen also it can react with the many ways. So based on this hydrogen and oxygen, he grouped the elements by using the atomic masses to arrange the elements, not only by reaction which he has found, but also along with this reaction, Mendeleev arranged those elements on the basis of the increasing order of their atomic masses. Okay, and another important thing here you have to note it down is the formula of hydrates and oxides were very important, because this formula of hydrates and oxides, they formed by an element, they were treated as one of the basic property of the element for its classification, because it was a critical parameter for the classification of elements. As I told you now, XH, XH2 or XO, X2O, X2O3, all these were based on the formula of hydrates and oxides. Correct? And then what he did was, there were 63 elements, correct? So he took 63 different cards and on each of this card, he wrote the element name. I mean, he sorted out the elements with the similar properties and he observed most of the elements got a place in the periodic table, and then he arranged in the increasing order of their atomic masses. So this we understood, right? After this, what he did was, he arranged the elements. How many elements were there? There were 63 elements, right? So he arranged all the 63 elements in the 63 different cards. For example, if an element is X, what happened? He wrote this X element and he reacted this X with the hydrogen as well as the oxygen. And then he also wrote the atomic mass. For example, suppose take an atomic mass of this element, maybe 30. And let us take another element X, which is having the atomic mass of 15, and this element is also reacting with both the hydrogen, that is hydrates and oxides, right? So he did this for all the 63 elements. So he took all the 63 elements and he reacted all the 63 elements with the hydrates and oxides. And once he had all the values, now what happened, he knows the name of all the 63 elements and their atomic mass and the hydrates and oxides which are formed. I repeat once again. So there were 63 elements, right? All the 63 elements which were found during that time, what Mendeleev did was, Mendeleev took the 63 different cards and he wrote all the 63 elements name on the 63 different cards, and he reacted those 63 elements with hydrides as well as the oxides, right? And he found out some of the compound out of it by reacting with both hydrates and oxides, correct? And later he also wrote the atomic mass on the card. For example, suppose this is a card and the element is X, and element got the compound like XH or X2O, and followed by he also wrote the atomic mass. For example, consider an atomic mass of 12, correct? So in this way, what happened, he did for all the 63 elements. Once he had found out the values of all the 63 elements, what happened now, it was easy for him to find out to know their atomic masses and the hydrates which are formed out of those elements and the oxides which are formed out of those elements. Now Mendeleev grouped these elements based on the reaction of hydrates and oxides, because that was a critical thing which was found, correct? And if you look at the octave, what he did was, the octave was arranged the elements on the basis of their increasing order of their atomic masses. Only he look for the increasing order of their atomic masses, and he also found out the periodicity, correct? But Mendeleev not only looking at the atomic mass, but also he is looking for the fundamental properties, physical as well as the chemical properties of the elements, correct? So what he did, he sorted out the elements with the similar properties, as I told now, XH, XH2 or X2O. So the elements with the similar properties he sorted out, and he observed that the most of the elements got the place in the periodic table, right? And he arranged those elements on the basis of the increasing order of their atomic masses, because the atomic number was not it was not found at time. It was only all about atomic, so atomic number was not found during that time. It was all about atomic mass. So on the basis of the atomic mass, Mendeleev arranged the elements in the periodic table. Clear? It was observed that there was periodic reoccurrence of the elements with the similar physical and chemical properties. I told you what is meant by periodic reoccurrence, means some of the elements were having the similar property, right? He also observed, Mendeleev also observed that periodic reoccurrence of elements which are having the similar physical as well as the chemical property. And finally, on the basis of this, whatever he has found out, on the basis of this, Mendeleev formulated the periodic law. I repeat, on the basis of these things, whatever he has found out, the elements he has segregated on the basis of the chemical properties, he has reacted with the hydrates and oxides, right? And he also given the atomic mass, and he arranged those elements in the increasing order of their atomic masses, right? So on the basis of all these things, Mendeleev formulated a law, and this law states that the properties of the elements or the periodic functions of their atomic masses, very important, they will ask you in the examination. There are two important laws, that is, one is Mendeleev's periodic law, and the another thing is the modern periodic law, which I'm going to teach you in another session. So for this session you have to understand the Mendeleev's periodic law. So what does the Mendeleev periodic law states? It states that the properties of the elements or the periodic functions of their atomic masses. So this is a law which also gives the Mendeleev periodic. So this is the law which is called as the Mendeleev periodic law. Here he used the atomic masses. In this law he used the atomic masses, not the atomic number. Correct? So remember, not the atomic number, because the atomic number was not even discovered at that time. Okay, and the based on the atomic masses which was found by the Mendeleev, he also found out some of the chemical reactions. How did he found out the chemical reactions? You know that he has reacted the elements with both the hydrogen, that is the hydrides and oxides. Correct? I hope you all clear. You understood this concept. Now let us look at a table, the Mendeleev's periodic table. So it will give much clarity to understand. So this is the table which was found by the Mendeleev. So if you look at this table, you can see the oxides are found in one row. See, this is the oxide, for example. See, R2O, RO, R2O3, RO2, R2O5, RO5. All these things they're all called as oxides. R is considered to be an element which is found in this group. It may be any element which is found in this group. Okay, so these are considered to be the oxides. R2O, RO, R2O3, RO2, R2O5. These are all oxides. Okay, and these are called as hydrides. RH, RH2, RH3, RH4, RH5. So all these are considered to be the hydrides. So there were different hydrides and oxides he found. So based on this based on this hydrides and oxides which he found, he clubbed the elements in the periodic table. Correct? So far this combination he found, whatever the combination he has seen, he has clubbed the elements, he found the elements in the group. For example, if suppose the hydrogen, if it is reacting with the R2O, it may be now H2O. I told you that the R may be the element and O is the oxide. So now I am replacing this hydrogen in the place of R. So R is any element which is found in this group. Okay, so now R2O means it is H2O. Correct? So one more thing I'll tell you. Suppose if it is reacting with the hydrides, now then there is RH, right? Now if hydrogen is reacting with another hydrogen, then it will be RH, that is 2 atoms of hydrogen, then it is H2. Correct? So one more thing, you can also react the next element, that is lithium, right? Now let us react this, that is R2O, R may be any element, right? Now let us take lithium. So it is Li. Now R2O means it is Li2O. Then RH means it is LiH. It is LiH. Correct? So this is how he reacted the elements. This is how he reacted the elements, and he clubbed the elements based on the reactions which were found in the similar groups. Clear? And if you see, there are so many rows here, right? You can see there are rows and columns here. Correct? So Mendeleev called his vertical columns as groups. What are the columns? These are the columns, right? So these are the columns. So Mendeleev called his vertical columns as groups. How many groups are there? There are totally 8 groups. That is group 1, group 2, group 3, group 4, group 5, group 6, group 7 and group 8. There are totally 8 groups. And he also called his horizontal rows as periods. Which are the horizontal rows? So these are the horizontal rows. Then how many rows are there? How many periods are there? There are totally 6 periods. Period 1, period 2, period 3, 4, period 5, period 6. There are totally 6 periods and 8 groups in the Mendeleev's periodic table. Correct? And he called this horizontal rows as the periods and the vertical columns as groups. So you should remember this. Okay, so now next let us understand the merits and demerits of the Mendeleev's periodic table. I mean, what are the advantages and the disadvantages of the Mendeleev's periodic table? Okay, So let us understand the achievements of the Mendeleev's periodic table. First thing is, he predicted some of the elements that were not discovered at that time. I repeat, Mendeleev predicted some of the elements which were not at all discovered at that time. Because when he was arranging the elements, he found that some elements were missing in his table. Because of those elements, because why I can say you why he has missed out those elements, because there was no proper atomic masses for those elements which were missed. Okay, so because of elements which were not having the atomic masses, so some of the periods or the slots were empty in his table, and then he guessed what that element may be. Right, he guessed the element. So he guessed that there will be an element which will be found in the future, and it will be having an atomic mass of 68 in future, and he called that element as Eka aluminium. I repeat this topic. So I'm telling you the advantages of the Mendeleev periodic table. So I told that the Mendeleev predicted some of the elements which were not discovered at that time. Because why he has predicted? Because while he was arranging the elements in his periodic table in the increasing order of their atomic masses, he found that some of the elements were missing in his table. If let us look at his table, you can see, right? So there is some gap here. You can see there is some gap here. Here also there is some gap, right? So there were some gaps in his periodic table. So because of this, he predicted some of the elements that were not discovered at that time, and he arranged those elements, the missing elements in his table. And he also guessed there will be an element which will be found in the future. I repeat, he predicted one of the element, and he guessed that there will be an element which will be found in the future, which will be having the atomic mass of 68, in future, and he called that element as the Eka aluminium. He called that element as Eka aluminium because it should be found along with the aluminium, and the element will be found in the future, and in the future it will be called as gallium. When he found out, he said that it is Eka aluminium because it was along with the aluminium, and he also guessed this Eka aluminium, it is called as gallium in future. Clear? This Eka aluminium is called as the gallium in future. And he also guessed the formula of oxides as well as the chlorides for this element which he has found out during, that is the element which he had guessed that time. So he reacted the Eka aluminium along with both the oxides, the formula of oxides and the chlorides. And for the Eka aluminium, he got the oxides like this, that is E2O3, and the formula of chloride for the Eka aluminum, it is ECl3. It was all an assumption of the Mendeleev, please remember. Okay, and for the gallium, he thought that the Eka aluminum will be called as gallium in future, right? Then that gallium will be having the formula like this, that is maybe Ga2O3 and GaCl3. He has just predicted. Okay, so Mendeleev's periodic table have now Eka aluminium, which is called as the gallium in future, and we also understood that the formula of oxides and chlorides for these elements. Correct? He could also predict the property of some of the elements based on their position also. Let us look at the periodic table. For example, if you look at the periodic table, he could say that how the elements could form the hydrides and oxides. The way they form, how the elements can form the hydrides and oxides. For example, before also I have given you some of the examples. See, I was telling you that suppose if the column 1 is having the oxides like R2O, and if you react this any element if you react, for example, I was telling you about hydrogen. If hydrogen is reacting with the oxides, then R2O may be the H2O because R is the any element. Correct. So now let us look at the another element in some of the different table. Okay, now let us take the Br. So this is in the 7th group. So its formula is R2O3. Correct. This formula is R2. This is oxide's formula is R2O3. And now this R2O3 may be Br2O3. Br2O3. And it is in the 7th group. Correct. So if suppose this Br, if it reacts with the formula of hydrates, it may be BRH, because the formula is RH, right? RH means R is the element, R is the Br, and H is the hydrate, right? So he has guessed. So all those things he has guessed. Hope you all got an idea what I'm telling to you, right? So just by looking at the position of the element, he found out the hydrates and oxides, and he also could accommodate the isotopes in his table, because isotopes were also found during that time. So he could also accommodate the isotopes in his table. Clear? Hope you got an idea what is this I was telling you. So now let us understand the limitations or the disadvantages of the Mendeleev's periodic table. The first thing, that the isotopes were also discovered. As I told you, the isotopes were discovered at that time, right? So when the noble gases were discovered, the position of isotopes could not be explained. He has arranged some of the elements in his table, but as he also given the place for the isotopes in his table, but the position for the isotopes could not be explained by the Mendel in detail. Okay, so because the isotopes are the elements, you know what are isotopes, right? Isotopes are the elements which are having the same atomic number but different mass number. Correct. For example, some of the isotopes may be like C612 and C613, C614, right? These are all the isotopes of carbon. Just now think, children, what I'm telling to you is, I was telling you that the Mendeleev arranged the elements on the basis of the increasing order of their atomic mass. So now just think, can the carbon can accommodate 3 slots in the periodic table? Can it be possible for a single element to give 3 different positions in the periodic table? No, right? Because the isotopes or the elements, they're having the same atomic number, but they're having the different atomic mass. And depending on the mass number, the Mendeleev was arranging the elements in a table not on the basis of atomic number, because the atomic number was not at all discovered during that time. Correct? So the C612, C613, C614, all these are the isotopes of carbon. Since they have the different atomic mass, they should be placed differently, but it was not possible, right? Because for one element, we can give only one place. That was not allowed in the table. I mean, the same element cannot be placed repeatedly in the different places, correct? So, the position of isotopes could not be explained. Even though isotopes were discovered, he could not explain the position for the isotopes. Correct? And the next, you can see that the wrong order of atomic mass is also seen in some cases, and that could not be explained. I repeat, the wrong order of the atomic masses. As I told you, the elements has to be arranged in the increasing order of atomic mass. Suppose if an element having the atomic mass, take an element, okay, let us take an element cobalt. Suppose if it is having the atomic mass of 58.9, correct? So now this cobalt, which is having the atomic mass of 58.9, and let us take another element, that is the nickel. Okay, which is having the atomic mass of 58.7, right? So this has to be arranged in the increasing order, but Mendeleev arranged the cobalt first and the nickel next. I mean, it is a wrong order of the arrangement of atomic masses. I repeat, wrong order of atomic masses is being seen and that could not be explained. Suppose if the atomic mass is 58.7, this is lesser than 58.9, then nickel has to come before the cobalt, right? But it is seen that the cobalt was arranged first and the nickel was arranged followed by the cobalt. So this arrangement was actually the wrong because it was not in the increasing order. Correct? So this is also one of the limitation. So another limitation is hydrogen was not assigned the correct position. In the periodic table, the hydrogen was not assigned the correct position because the hydrogen has the property of both the alkali metal as well as the halogen metal. I repeat, the hydrogen has the property of both the alkali metal as well as the halogen metal. Because hydrogen, take an example, if the element is sodium and the another element may be the chlorine, just think the hydrogen can behave like both sodium as well as the chlorine. Because as I told you, it can behave both as the alkali metal as well as the halogen metal. Correct. So if it is behaving like both alkali metal and halogen metal, what happened? The hydrogen could not be assigned in a proper position. Correct. But even though he is having all these problems, he classified the hydrogen on the basis of the hydrates and oxides. He reacted the element hydrogen with the hydrates and oxides and he has given the position for the hydrogen. Correct. So now Mendeleev could not answer the question. So after this limitation, what happened was, so there was a question which was arise during that time. So Mendeleev could not answer for this question. What was the question? So the question is like this. It is possible to have an element with the atomic mass 3 placed between the hydrogen and the helium. I repeat the question. So there was a question which was asked. So the question was like this. It was possible to have an element with the atomic mass of 3. Means if there is an element X which is having an atomic mass 3, can this element be placed between the hydrogen? What is the mass of hydrogen? The mass of hydrogen is 1, right? And followed by the mass of helium. Helium is 4. So now the question is, can it be possible for an element X to come in between? That is in between the hydrogen and helium. This is according to the mass. Please don't confuse, because when I was talking in the previous year about the atomic number, we know that the hydrogen is having the atomic number 1 followed by the helium is having the atomic number 2. Correct? So here we are talking about the atomic mass. The question is, can we put an element in between the hydrogen and helium with the atomic mass having 3? So this was a question. Correct. So for this, what Mendeleev did was having a confusion. Can I put or not? So he was in a dilemma actually. So when we look at the atomic mass of an element, we can see that there are so many decimal numbers. Most of the elements are having the atomic mass in the form of decimal numbers, not in the form of rational numbers. So if we think that if there will be an element in between the hydrogen and helium with the mass 3, we cannot give the clarity for this, because in between the hydrogen and helium, if I think the hydrogen is having the atomic mass 1 and the helium is having the atomic mass 4, so there may be so many elements, that is the elements may have the atomic mass of 1.1, 1.2, 1.3 and so on, right? Or in between 1 and 4, it may also start from 2.1, 2.2, 2.3. So if we look at like this, in between the hydrogen and helium, we can place so many elements, right? But it was not possible, because the hydrogen is having the atomic mass 1 and followed by helium is having the atomic mass 4. We cannot give the clarity that an element with the atomic mass 3 can be placed between the hydrogen and helium. So this was the question which could not be answered by the Mendeleev. He cannot say, he could not answer whether he can place an element which is having the atomic mass 3 between the hydrogen and helium. He could not answer for this question. Correct? So if we talk about the atomic number, yeah, it is possible. We can arrange it in the increasing order. But when I talk about the atomic mass, it is not possible, because as I told you, the atomic masses, most of the elements are having the atomic masses in the form of decimals, but it is not in the form of rational numbers. So it was not possible to tell or to answer this question. Correct? So these are all the limitations of the Mendeleev's periodic table. So we have understood the merits and demerits, that is the advantages and the disadvantages of the Mendeleev's periodic table. So in the next session, I will be helping you to solve some of the questions which is related to these topics. Thank you.